back to Sikkim and start attending physically the lab classes at least, because you're going to get an environment first thing, because homely environment is never going to be a comfortable and favorable environment for serious studies. So, I mean, labs are always open. Ultimately, today or tomorrow, you have to come and you have to arrange an accommodations over here. So, my suggestion is that I think if instead of getting it delayed, I think you should start coming in the department, start using the labs and all, and attend the classes from the lab itself. Then it would be better. But it is true that since labs are open, if I mean you can definitely going to get a very good help of like this what is called um, your internet connectivity, uh, direct interactions with the teachers and all that you're going to get it. But ultimately the decision is up to you. If you want, then I have told earlier also, labs are always remain open. You can use those resources. Now, regarding this particular paper, the software engineering paper, uh, I think in the new syllabus we have removed that paper. But software engineering, I think you're going to be the last batch. We're going to study software engineering in CA course. So this is purely a kind of a theoretical paper. You do not have this burden of doing programs and all. It's not there. It's a theoretical paper. So I normally don't teach this paper. This year, but this time I have taken just because of some other reason I have taken that particular paper, software engineering. So it's purely a kind of a theoretical storytelling kind of paper, but it's very interesting. That is the only thing. It's not just it's theoretical doesn't mean since you do not have program or lab. That's why it's not relevant. It's very relevant if you are planning to go for industry. Okay, because today or tomorrow you need some basic idea or knowledge is what are the practices which is happening in um, industry. So that way it's very important. Like the software thing, ultimately big companies, giant multinational software companies, they normally follow certain kind of principles, and what with that principles what we call it as software engineering, and mm, and basically, but this is also true. Like whatever you're going to study, it may not be very standard kind of study, because it has been observed the academic study and the actual practices in the industry are drastically uh, varying with each other. Okay, whatever you'll study, possibly you'll observe that their style of working in a particular industry is completely something different, and one company's way of working is different from the other company's way of working. Okay, so that way it has been observed that these particular codes are being very less relevance in terms of your practical usability or actual implementation in the ground or in the industry. So, but anyway, there are few things which you're going to learn through this particular course, and this is quite interesting because of course these are the things which are earlier it has also been practiced, and there are whatever the core ideas which almost all companies they need to follow. This is going to be studied discussed over there, but there are different styles, working styles are there in industry. So that actually it actually varies. It varies from industry to industry, from academics to industry, and that's why it is very good. And from your NEET exam point of view or some other higher studies related examination point of view, this software engineering paper is very important. So that's why it is always, I mean, advised. You have to study these things more uh, lightly way instead of again not doing any markup. But it's definitely a kind of a conceptual paper, theoretical paper. No such kind of practical related kind of thing or problem solving kind of things. You're not going to get it. over there, except very few minor kind of numerical problems it may be there. But other than that, almost all are basically storytelling. So no need to take any kind of a huge burden of like that, like the other papers that you have studied. So and one more thing, like since you have very less time, almost 3 months you have for your semester, because this semester is going to be very short duration semester. That way, I feel I mean we can able to finish it up as quick as possible the whole course as far as possible, so that you don't have to face much difficulties into that. So we'll deal accordingly to cover up as much as possible to cover up this particular course. So now let us start very gently this particular. One. So is it visible the full screen? Whether my screen is visible?
Yes,
Yes,
sir.
sir.
It's coming full screen.
Yes, sir.
Right. So basically we're going to study what we called it as software engineering. You have heard about electrical engineering, mechanical engineering, civil engineering, but this is something new, that is called software engineering. So there is nothing like software departments. The civil engineering department have a separate department. Chemical engineering department have a separate chemical department. Mechanical engineering department have a separate mechanical engineering course and department, but you do not have a separate full-fledged software engineering course for that. Yes, there are few universities they are offering explicitly some in the name of software engineering, or some honors course of software engineering. But here we normally do only one particular paper that actually covers the software engineering course. But it's very very important, because why nowadays the software engineering, our softwares are getting crashed, fail. This is because people do not take this software engineering very seriously. That is the reason why most of the softwares are not either working or having lot of issues in long run. Okay, because you are using lot of software nowadays. Everywhere it's software and software. But most of the time, softwares are being developed without very ad hoc basis, without using any particular standard working procedures. Okay, so that what the software engineer tells about. When you are going to develop a software, what are the ways that you should go and adapt, so that you can avoid such kind of abnormal situations, like crashing a software is not compatible with some of the environments. Okay, so and it's not satisfying some of the requirements and all. So that's why it's very important. Now, whatever applications or apps that you are using, they are basically, corporate sector's own ideas. They try to implement in terms of software. But the software, majority of the softwares are customer dependent or customer need dependent. So normally what happens, software they want some software which will going to be implemented in their organizations, and then organizations or the customer will going to expect that the software going to perform as per the expectation. So now let us assume in Sikkim University is using some software nowadays to manage different activities in the what is called in the university administrations, in the finance, in library, in exam. So that means they always have to have a kind of a reliability in that. Say, let us assume for examinations. Now, examinations are almost nowadays it's online. Okay, so results are being already stored in the uploaded in the database. Now, as a students, you can able to watch that things. So as a teachers, what we do, we always depend on that software. We are uploading these things, and we expect that whatever we are uploading, it will going to be remain in there. And as a student, whenever we see that result, you'll assume that this is the mark that has been uploaded by a teacher. So that is the marks, true marks that you have achieved. Now if my software is not reliable, if my software is not performing well, then what will happen? There may be some chances that there is a loss of data. There may be alterations of the data, because of which both the parties will going to suffer. Okay, because because you will depend on that data. Am I right? You depend on that system. So, but if your system is having some flaws, naturally you will assume that this is the marks that has been uploaded, and teachers will feel that this is the marks that we have uploaded, so it is there and it is rightly has gone to the student. So now what may happen if this is this if my software is not performing correctly, then your marks may be interchanged with the some others mark. Your marks, the digits which has been entered, that may alter, and that may give a kind of a wrong kind of thing. So anything is possible, and the examination is also printing that what is called mark sheets based on the data uploaded. So they always, in every time, they have a kind of a assumptions whatever software has been developed, these are foolproof, and these are there will be no error can happen over there. Okay. So but that is the thing, like the Dijkstra, I mean, I don't know whether you have studied Dijkstra's algorithm or not. You have studied Dijkstra's algorithm? Dijkstra's algorithm in data structure, it was not there because you do not have any. But in graph theory, whether you have heard about Dijkstra?
Yes, sir.
So the extra what it's a very good code. What it is there, like debugging, debugging is basically a process through which you are actually um, I mean removing the what is called the software bugs or error. But what happens when you do the programming, this is the way through which you are actually giving more and more bugs into that or error into your program. So that means both programming is, see, we are what we used to do right till now. We are giving more emphasis on programming, because we are trying to build that thing, but we hardly think much about what are the errors that actually are additionally we are putting into our system or in our program. Okay, I'll say whatever you have written so far, these are all programs. Okay, these are not softwares. Okay, so so whenever you are going writing some codes and programs, side by side you are actually I mean you are putting so many errors and all. But the problem here is that the issue here is that, like, since it has been designed for you, so you'll write some program and you'll run your program of your own, and then try to solve some issues problems by your own. So that means you are the only users of your program. But software is something like that, which is not, you are not going to be the main user. You are basically developing this software for some end user, for some customers. So that's why you don't know like what kind of way the people will going to use your software. And obviously if it is not well designed software, naturally your program, the function, your software is going to crash. So that's why in a big company, in corporate sectors, the company, they basically give very large emphasis on removing the bugs. Okay, and then doing the software programming. Software is the way that you have developed or you have written the code. Possibly they will not going to entertain such kind of things. They have their own style of programming. I mean, when you go inside, they have their own I mean process, software making process they're going to follow, and you have to follow that thing, and accordingly you have to write your codes or program for the software. Okay, so that's why both the things, as much as programming you're going to do it over there, more and more errors, the chances of being introduced to be introduced the bugs will going to be higher in that case. Okay? So just a slides. Engineering is that now mention whatever now what we're going to for is not software, they're basically programs. So there will be some difference between programs and software. Of course, to write software you need programs. And then we'll see how the software engineering has grown up. Okay. And let's see, and then more important is we're going to see different style of developing softwares in industry, and we normally call it as a life cycle of that particular software. Okay. Now, machines. Now, basically, the fact here is that what someone wants to illustrate that you will start your career with studying Unix, okay, and then you will study C, Java, .NET, everything you are doing in engineering course or your MCA course. I mean, it's basically for the since this as for the year, this is basically a engineering course. But anyway, for you also this is applicable. But the part here is that like after doing so many things, if you are not a very good becomes a very good software engineer, then ultimately it will going to be ended up of doing some marketing kind of thing or clerical job kind of thing, without I mean there is no use of whatever the skills that you have developed during your masters or your bachelor courses. So that is the ground reality. Then that most of the students, because they do not gather a very good programming skills, they basically end up with some kind of clerical job or marketing job, and they have to no need for these C++, Java skills. They are doing something called MS Excel based job, MS Word based job, which other also can do it without the knowledge of whatever you have learned during this thing. So that is the dark side of these things. Like if you are not very serious in programming or you are not doing the program over there. So this is a kind of an illustrations that actually happening over there. Now some more reality in terms of software engineers, software engineers or the software engineering. See, as I mentioned, like the software is not for a single user. It's basically for the customers, even in the large customers. Okay, and then let us assume say your railway ticketing system. Okay, railway ticketing system. So what the railway normally do, they have their own requirement, and it's normally they try to give that idea to what is their requirement, and it normally gives to the company, and then company tries to understand what is the use, or so what is the use case or what is the requirement that customer is actually looking for. Okay, and so if the illustration is something like that, someone wants a very nice some hurdle or seesaw, whatever it is. Uh, so I mean, if they are the customers having a vision or views or something like that, it will going to be very nice kind of a pedal. So so I mean, and then they what happens? They are actually dreaming, viewing. this kind of expectation they have. And normally it has to be captured by what is called your um, by the you have to transfer it to the what is called your by the analyst, or some analyst who are the architect, software architect. Normally in industry they have a number of hierarchies which are there. So there are some analysts are there, software analysts are there, or architects are there. They try to understand with the customer's need, with a number of meetings, okay, document sharings and everything that actually happens. That what is actually you want, okay, what is actually you want. They may have their own existing system, okay, with the customer. Say for example, examination department of Sikkim University, they want to develop a software automatic which will automatize the entire process of examination conduction, mark submissions, certificate generations, everything that they expect that it is going to happen. Okay, so now they normally try to sit with the software people, the people, the company say TCS. So TCS is interested to develop a software for Sikkim University. So the analyst, senior analyst or architect, they normally sit with the what is called with the customers, or the examination department staff, or the control of examinations, try to understand what is their need, what they want. Now, because see, you are actually transferring something which is there in your mind, and to be captured by someone who is not actually related to the examination department. So naturally, since they are not familiar well with the system, so naturally it will be difficult for them to understand what is actually the customer or the examination department wants. So somewhere after a series of meetings, series of demonstrations, series of exchange of ideas of how the manual system is happening, or how the examination system currently working, and what they want. So after that, what they did it basically, analysts will going to design some fancy kind of thing, though, but it's not actually the real reflection of the customer's need. Okay, so you see the first picture. So since the customer wants something, that the customer, anyone can swing over there. So they cut that something, doing their own way. They thought of it, this is the way how we can implement or develop a kind of a software. Okay, and then once they design it, they normally give it to the programmer to implement. Now, if the programmers again, it's basically communication between analyst or architect and with the programmer. So that then again there may be some miscommunications may happen, and ultimately if the programmers are not very good coder, so naturally they are going to come up with something which is going to be useless at the end. Okay, or if it is useless for certain period of time, after long run use, the software is not going to be any use. I can tell you the current experience with the examination software that we are using. There are some of the features they have added, but most of the features are either not there, or somewhere they are useless, or they don't follow some kind of modern features that can be incorporated over there. Why? Because they once they develop, years after years people are using, they never upgrade, because upgradations required again your what is called money and everything. So they don't they avoid. Okay, so that's why now the examination department is planning to go for a new software. Okay, so that issue, work is going on how to do that thing. So the problem main is that they have developed somewhere, they are not very effective, and if the programmers are not very skilled, then possibly they will going to incorporate more number of bugs, and it would be very difficult to use that software, and it will going to remain useless. And lot of such kind of examples are available in Unity. This is because one is communication gap between the different parties. or different layers. One is customer, another is analyst, another is programmer. This is one issue. And the other issue is that, like, if the programmers are very poor coder or poor programmer, possibly they're going to incorporate more and more bugs or errors into the program, and it leads to the crashing of the software after a certain period of time. So, is there any queries? Do you have anything in your mind? You can ask me. Anything which crop up your mind? Am I audible?
Sir,
Yes.
sir, DevOps engineer is same as software engineer or different?
Tell me once again.
Sir, sir, DevOps engineer क्या होता है? और software engineer?
No, no. Again, what above? I'm not getting. Tell me once again.
Sir,
Tell me
what
once
is the
again.
difference between DevOps engineer and software engineer?
Develop engineer.
DevOps.
No, that I don't know. I don't have any DevOps. This is something new term. That I don't know. Sorry. Any other query? So what is basically software engineering? It's basically like the other engineering branches. It's an approach of developing a product. Okay, it's an approach of developing a product. Okay, so suppose some you are developing a, well, some company, they are developing a what is called air conditioning. Okay, so it's not going to be an arbitrary kind of thing. Am I right? So there are different steps which need to be followed for developing creating a AC of the product like AC. Similarly, if you go for construction of a building, okay, construction of a building, it cannot be very arbitrary kind of thing, am I right? So, say for example, if someone asks some kind of what is called constructing a wall. Okay, constructing a wall is relatively easy. So some way, I mean, you just put the bricks one after another somewhere with the cement, and then some way you can build a kind of a wall. But again, it's having some issues if your wall is not uh, properly perpendicular to the earth. Possibly it will incline in one day in one side, and it will going to be crashed. Okay, so that means there is some systematic way that is possible. But anyway, if someone asks you, you can some way roughly you can build a wall. But if I mean someone asks you to construct a building or a flat or multi-story building, so do you feel that it's somewhat like a creating a wall? So it's never possible, because you need a kind of a systematic way and lot of phases that you have to pass through to construct a building. Otherwise, there is a huge kind of a your what is called a kind of a dangers may be associated with them in future. A building may collapse. Okay, if the laborers or the mysteries are not good, even while doing these things, the basically the civil engineers, they normally design plan in a piece of paper, so that's why after that only it goes phase by phase. Nobody can come and immediately they don't start constructing a building, because it's going to be a very dangerous kind of thing if they don't follow certain kind of process. So I mean, if I draw these things analogy with your case, like, you can, as a programmer, whatever you have done, it's basically something like building a wall. Okay, building a wall, that you can do it. If someone asks you to building a wall, that you can do it. But if someone asks you to develop a software, possibly it will not going to be possible for you alone. Okay, because you, first of all, you are number one alone, because software development is not like a single man, single person task. It is going to be a teamwork. Number one. Number two, it's having a well planning, designing, everything like a building construction, and obviously you need a very good set of programmers. Okay, a good set of skilled programmers. Otherwise, your things will going to be, though your planning is very good, your design is very good, everything is absolutely fine, but if your ultimate mysteries, mystery in construction, if it is not very well trained, possibly you know what is the consequences that may happen over there. So same thing that happens in the software, because see, some of the software, if it is crashes, it's not matters much, but there are some softwares which are really very very important. And it should not malfunction somewhere. Maybe because of the wrong use of that, maybe because of wrong programming skills, it may happen at any time. If you can remember one I mean, instance, like few days back, I don't know what's the uh, ground reality, but as the way it has been explained that few months back, one missile has been crashed in, launched from India and crashed in Pakistan, and there is a lot of things happen over there, and then later on, government has given a clarification that this is some kind of mal functioning happen in that missile. So because these are all software driven, software operated kind of arms. So if it is really true, the way government has given an explanation or clarification, if it is really true, though normally it not happen, then it's a very big blunder that happened, that there may be some errors, flaws in the software, because of which, or because of the erroneous, or user can use it in any way. Okay, then you cannot restrict user key, you have to use that thing in that way. They are always be given the freedom of using that software at in different ways. But your system should be very very proof, so that it should able to handle such kind of situations. So if it reacts according to that, possibly it may create a havoc in different scenario situations. Um, even in say that though it's very very good software so far, you can say that railway reservation system. You see such a big reservation system, such a big software, and you see how many every now and then what is called people are reserving the seats. So many trains are flying every day, and then so many passengers are booking their tickets. So can you imagine, like, you have booked a ticket, and at the same time there is a clash happen between your set with the other passengers. So far, I think it's almost nil such kind of situations. Neil, I don't know. I have not heard any such kind of situations that happen. Like it clashes. That two persons has been assigned with the same reservation seat, reserved seat in the same train. So it's very unlikely. I have never heard. But since this is very well developed software, that's why till now railway never faced such kind of situations. So now, how it has happened? Basically, whatever you develop doing in engineering work, most of the time there is a huge role of past experience, because people learn from the experiences. Okay, what happened in the past, they gather that experience, and then in the next time they add this kind of experience. Keep no no. See, in the last time we developed in that way, so that actually creates a lot of problem. Let us try with this way. So these past experiences, it's very very important for for developing any big thing, any, not only software, it can be anything that that basically plays a big role over there. So this actually what things that happens. the different techniques that you are doing, what methodologies you are going to adopt, and these are the different guidelines that should going to be there based on the past experience for developing these kind of things. Say nowadays for any software, you have lot of modern technologies which are available. The different JavaScripts are available, people are doing. So now, if there are so many things which are available now, until and unless people having a past experience that for this kind of work, whether a particular JavaScript, say React.js, or Node.js, or any other JavaScripts, whatever you are using, or whether you are using PHP, or whether you go for a JavaScript. So I mean, if you as a first time user, if you go naturally, you don't know what will going to be happen at the end, whether it will going to be end up at any moment, is there any issues may crop up. So now, but if you have a very good senior people together with you, and they are going to share with experience, see, this kind of software we have developed in the past and it crashes. It could not able to do with these technologies or methodologies. So let us switch it to that kind of technologies or methodologies. So until unless there are some past experience are taking lead over there, possibly you may end up with something which is either crashed or it's not end up with nothing. Okay, so that's why. So normally software engineering, I mean software industry, they have a very there is a big role of senior people in the industry because their experience matters. Having some issues. Windows is very bad kind of operating system. Lot of this updations happening. When if you stop, also that's going on in the background and it's making it slow. Really very fed up. It's handy. That's why what actually software engineering or any engineering they incorporate, as I mentioned, that past experiences is playing a very big role. Okay, and either they document it in the form of a kind of a manuals, documentations, guidelines. Okay, guidelines, and then that guidelines is going to be followed by the industry year after year. Okay, until unless some new experience they are encountering, some issues they are encountering, normally they follow, and that is why the industry to industry these things actually vary. Okay, because a lot of different kind of projects they are handling, different type of skilled persons are going to be there, and they normally based on their past experience they normally create a kind of a guidelines, and then that's why it's never going to be the same for all the companies together. But roughly there are some core part which are there that normally they follow. Okay, it basically provide a kind of a theoretical basis, and there are different quantitative techniques which are there. Okay, so we'll discuss it later on, and there may be some kind of thumb rule that they follow, and that is the most dangerous things like thumb rule, because thumb rule means ki this is the way how we are doing. Okay, if you go to some industry, not very big companies, so normally they say "Ki we are using this way, we are developing these things, or we are developing a software product in this way." So normally they follow some thumb rule. So but thumb rule is not very going to be a I mean a good idea, you will observe that there are some software companies which having all ISO 900, 9001, ISO 9002 software companies and all CMM level. There are something called CMM level companies and all. So there are some ratings which are there for the company, and these ratings they are getting just because of what type of practices they are following, what type of principles they are following for these things. Small companies, if you go and join, possibly you're not going to get anything. There will be some few senior people. They will ask, do this thing, do that thing. Okay, but they don't say "Ki this is the way how the things will going to happen. But very large, well-known corporates like Microsoft, TCS, okay, Google, they have their own style of working, and they you have to follow their way of working, and these are well experimented. That is the good thing. They are well experimented steps, so you can follow that thing. Okay, so I mean, that is the thing. You may switch it between the different alternatives. Like you may try with this a particular way, and then if it is not working, you can jump into some other approach. So problem here is that like I mean, it kills the time. Okay, it kills the time to try different models, different approaches. So that's why people in every company they follow a particular type of style of working. Okay, and obviously everything leads to the cost because you are not actually writing a code for normal use. You are basically writing a product. Okay, and product cannot be I mean, very costly. No one going to use. But of course, this is a ground reality that softwares are very costly in nature. Okay, very costly in nature because directly machines cannot manufacture software. You need human developers, and human developers are expensive. That's why the software costs are also increasing day by day. Okay? That is also quantifying the cost of the software is also it's a challenging thing how to quantify or how to assess the cost of that particular software. So we'll see some ways how we can calculate the possible cost of a particular software. Okay. Now, as the if I considering with the time passage of time, okay, and with the I mean improvement in the technologies or in the experience. Initially, what happens? Basically, it's a programming. We normally call it as an art. Okay, how good you can able to implement the logic. Okay, we are always talking about how logic so far. How good you can do. Say suppose. Uh, I mean, so that means basically you are trying with alternatives, your own creativity and everything that you're going to add it over there. Say suppose some in some of the problems you have to ask them to arrange the data in some way. So what you'll have to do, what you'll do, you know that if you put it in an array, some array, subsets you are storing some data in sorted order or so that it can help in quick searching. So naturally, what you'll do, you'll never going to use array because you know linear search is expensive. If you apply binary search, then you need to sort that array every time. So what will obvious thing is that like to have a very good programming, you'll go for a three kind of approaches and all that. Will do. But the fact is that I'm just giving a small example. But the fact is that I mean that for your own creativity and everything, you can make a very good, very effective data structure you are implementing and everything that you can do. But since there is nothing actually involved, the other past experiences on all these are not involved. But when you go for a kind of a big software development, possibly people aren't going to encourage much about these things like to implement it in. I'm just giving an example. Much implement encouraging what is called three options. they may ask you to write it in array and do the linear search. Now, as a student of computer science, you will not going to be very happy that your company or your super or your leader or boss, your senior, you're asking to write it in what is called in array, asking not in what is called in the tree. Okay, so you may feel bad, like what they're doing. If I do it in the future, that will going to be very effective. Am I right? If you implement it in a tree, that will going to searching will going to be very effective. Actually, what I'm doing, I'm just trying to give my own experience when I have worked in some small company. So I mean, what happens when you go for such kind of? I'm not talking about my experience in tree and array. I'm giving similar situations that actually happened with me. They asked me to do something. I said no. If I go, give me some time. I'll develop a small logic so that it will going to reduce the overall space requirement. So it took, I think, 1 day extra and all, and then there are a lot of issues happen. So they used to say, don't worry about space. You go for a very simplistic implementation. Okay, you go for a very simplistic implementation because we need to develop these things on time. Because as the time goes up, your cost of that things will going to be high. Okay, higher. So it will be very difficult for a company, because company not only look for the quality of the software, at the same time they also look for the benefit, cost, and everything. Now, as a developer, if you're a very good programmer, you may feel very bad, like why they are pushing it to me. Though since personally didn't like that thing, possibly that is the reason why I have never have just left that kind of job and came back, because I thought possibly that light is not for me. But in true sense, with the passage of time, what happens? People are more and more similar. Senior people, they join in the company, they gather experiences, and then after that, they will say, "Don't go by the tree, but go by the linear linked list." Because if you go for a what is called tree-based implementation of that data arrangement, it may increase your efficiency in searching, but the fact here is that the implementation itself is going to take time, and since that implementation is complex, possibly it may it may incorporate more bugs. And another important is that uh, there is something important phase is called maintenance. Okay, maintenance of a software. Maintenance means once your software is developed, in future if there is some bugs, there will be few people who will go inside of the code and then they'll try to debug it. Now, if your program is very cryptic, if your program is not understandable by the other people, possibly you may leave that company, or possibly you may not be involved in that maintenance course, maintenance job in the future. Then whosoever is going to be appointed for that particular positions or task, they it would be difficult for them to understand what you have written. So that's why company always prefer something which is very simple to implement, which is very quick to implement, and which is very easy to maintain. Okay, so how this has come? This has come with the time, with the experience. Okay, so basically that's why with the passage of time, with the increase in the technology, different technologies, the things become now engineering. Why engineering? Engineering means more and more past experiences has been incorporated while developing a product. So that's why it's a initially it was a craft, because you are free to do that thing. Sorry, art. You are showing a creativity, and then some way, experiences has been incorporated, and then people say do in this way, like thumb rule kind of thing. So we call it as a craft. So think in that way, and there is no systematic way. But again, as the times grown up, it increases now from the beginning. Now it's become a more systematic process, and what we call it as a engineering. Okay, that's why we call it as, because engineering means some systematic way. Okay, the systematic way to develop any product or develop, if it is software engineering, so we'll say that it's a basically like systematic approach process to develop a software. Okay, that's what we call it as a software engineering. Okay, uh, So these things you have already, I don't know what is going. Now, why we should, uh, I mean, study software engineering? Okay, what is the use of it? Okay. So, I mean, it seems whatever program you have written so far, this is a very small program. Okay, like find a number in an array, find a number in a binary tree, do these things. Very small things. So since it's a small, it's very easy to handle. It's having a very less complexity. Okay, anyone can go and they can understand and they can identify if there is any issues which are there, if there is any error. So it's relatively very easy. So, but the fact is that in your case, the number of lines in your code may be 10,000 maximum, 1,000. I believe how many lines you have code written so far? Maximum 1,000, 2,000 code. If it is if in your project it may be maybe 10,000 line of code. Nowadays, because of good number of packages, that also need to cut down like anything nowadays. But the thing that they think in case of software development, it's maybe going to be 1,000. I mean, sorry, the 1 lakh kind of more than 1 lakh lakhs of lines of code. Okay, LOC means lines of code. Okay, so that may be over there. And what actually happens, the complexity, okay, of that software, the understandability of the inner structure of the software is going to be increases with the size of that software. So that I can come back to the Dijkstra's code, that more and more program you're going to do it. That is more and more number of lines of code you are going to develop. More and more bugs will going to be incorporated, and it would be much more difficult to debug such kind of large code. So if I ask you to write a very big thing alone, I can give you. I mean, I'm sure that it would never going to be a error free. It will definitely going to be a lot of errors may be incorporated by you. So that's why I mean you need a very systematic approach to develop a large program, or we call it as a software. Okay, a large program. Naturally, to develop a software product, you need a large program. Okay, so as I have mentioned earlier also, that if you go on kind of an ad hoc approach, this is the way thumb rule if you're using, this is the way how we're going to do these things, and then and what will happen, it basically increases the complexity. Okay, so you'll observe these things whatever I am discussing today. You will observe when you will be in the next semester, when you will start doing your project and all. You'll observe, you will start writing the code at the beginning, which is actually not the right way. Okay, you have to plan very nicely how you're going to do that. But since because of the shortage of time, what you people do, you start writing the code and then you come back and then start designing. Okay, so this is not the right way to do that for a software development. Okay, software development need to be very kind of a systematic way, step by step. You need a good design, and then you have to go for a these things what is called implementation, and then you have to test that how it is performing and all. So these phases and all everything that we're going to study next gradually, how it is basically happening over there. So anyway, so the main idea here is that we need to understand that software engineering is not like developing something when ad hoc basis the way that we have done so far in your programming. Software engineering means you need to have a very systematic way to develop, integrate large programs. And so, what are those kind of things? How we can help? I mean, develop these things. I mean, what the two things that actually helps us to solve not only not only complex program, but I mean, programming problems. It can be any big things that you can do it more easier way is there because of these two ideas. One is called abstraction, another is called decomposition. So what is abstraction? Abstraction means like you are basically keeping the important things open and hiding the unnecessary part of them. Say for example, you are writing some C program. Now you would like to do say printf hello world. Okay, so what you basically do, you normally do it some library functions you're going to use it, and you know that if I use the printf and this is the way how I'm going to use printf, okay, and it will going to display on my screen in the printf. But in true sense, this is not that simple. Okay, this is not very simple. Why? Because the printf, it's a kind of an interface or the things that has been given it to the user. This is the way how you're going to use it. But inside printf, there are a lot of things which are there, which will going to take the text that you have entered over there, and it will going to display on your screen. So that is not very straightforward, but it has been kept hidden from you, okay, so that you don't have to much bother about how printf is working. Similarly, say for a kind of a television set or a laptop, say you are using. Now you are pressing a power button for a laptop or a TV, and it switch on, and then you have a login. You are going to do login, and then you start working. But we never give attention or importance to if I press that button, how it is happening inside, and if I logged in, what is actually happening over there, okay, inside. So at least we normally skip, ignore these more details, because more and more details it will going to be open it up to you. More and more it will going to be difficult for you to develop something very complex thing. So that is why what people do basically, they basically they do a kind of an abstractions, and in software especially abstraction is very important thing. And then another part is that what we call it as a decomposition. Decomposition means breaking, chopping a large problem, okay, and into some small part, and then a team of developers, they work in individual parts and develop, and then finally they try to integrate to develop the whole system. And this is the approach how people do it normally in software company, that they normally break. It's not given to a single person, because it's never possible to be solved the whole problem single-handedly. So that's why normally this has to be chopped. Okay, that decomposition, what we call it as a module, software module, and then each of the modules may be developed by a team or a particular person, okay, and some sub teams, and then once it has been done, they normally integrate, and that then you can say the software has been developed. Now I mean, whether you have studied object oriented programming, you already done.
Yes, sir.
Yes, sir.
So now so I think in object oriented programming you have come across these terms: abstraction,
Yes, sir.
decomposition also. Decomposition also. Yes or no? Modular development and all. Yes or no? Yes or no? Whether you have come across
No, sir.
decomposition? No. Okay. So what is abstractions? I mean, what abstractions you have studied in, or which one is the abstraction in object-oriented programming? Hmm? Which one is abstraction in object-oriented programming? Because this is a very important feature in object-oriented programming. That is called abstraction. Which one you have these things? Abstraction. Do you know? Which one is abstraction in object-oriented programming?
So interface.
Interface. No. Hmm? How we can implement abstraction? Hmm? Anyone? So basically, we have studied about class, object, and all. They are kind of an abstractions that normally keeps. Um, say for example, in a particular class or in an object. So I mean, as you have mentioned that interface. Interface is not that abstraction exactly. So the class or objects are basically the abstraction, where you they basically hide what is called basically hide the inner details that how it has been implemented, but it will going to give you a kind of a function that you need to just call that particular functions and you're going to work for it. Okay, so but it basically hides all the implementation details, and that is what we call it as an abstractions from there. Anyway, so in software engineering also what happens even nowadays, if you go for project work and all, I'm sure most of you are going to use packages. Okay, the packages which are available freely available for implementing any or solving a problem. So that packages itself is an abstraction. Okay, you are not going in details how it has been implemented. Rather, you are going to use some functions which are already being implemented, and the implemented details are there inside that package. So that itself is an abstraction. And the decomposition, what will happen? Suppose a big program you have taken up, and among yourself you are going to divide. Okay, this particular part you are going to develop, this particular part you are going to develop, another part is going to be developed. Three. So let us assume you have a three-member project group. So three of you are going to divide among yourself the sub part of that whole project, whole work. So that itself is called decomposition. Okay, how you are basically chopping, cutting, or distributing the sub parts, distributing to some sub part of the whole large problem. That is called decomposition. Anyway, now there are some major phases which are really important in software engineering point of view. I think during your undergraduate courses also you have studied all those things, like requirement analysis. Requirement analysis, that means what is the customer's need, that you have to understand well, and then that normally what we do it we the analyst normally they specify or write it in the documentation form, and what we call it as software requirement specification or SRS document. So that means called software specification. Okay, what is the use of that, or what is the functions or features of that software, what kind of things that it will going to be the software going to be do. And then I mean then once the specification has been captured, then it will going to be designed. Okay, and then it will go for your coding. Okay, your coding, programming, implementation, whatever you can tell. And then after that, very important is the testing. Okay, and then once the testing has been done, it will going to be delivered to the customer, and then after that there will be phase going to be started, that is called management, software management. Sorry, not management, maintenance. Okay, after testing there will be a maintenance, phase will going to be there, and it will going to be usually remain all throughout the life of that software. So maintenance is the most longest I mean duration phase in I mean software engineering, because till the after delivering the software maintenance starts, and it will going to be there till the end of that software. And of course, there is another important thing what we call it is the project management. Means how this, since it's a software development is a big project, we call it, and how we're going to manage these things on so that it can be done in timely basis. Okay, in timely basis that can be done, and proper principles to be followed for developing or I mean, some big projects. Okay. Uh, Now, again, why we should study software engineering? Because to acquire skill to become a better programmer. So naturally, programmer you have to be a very pro programmer. Why better programmer? Because what we mean by better programmer, because it means you can write more and more error-free, effective codes, so that actually ultimately increase the your productivity, because normally company don't wait long for your coding to be ended up. You have to deliver on time. Whatever tasks has been given to you, you have to do these things. And of course, the code should be error as much as possible error free. Okay, and that actually happens with the experience. That's why the freshers having less importance in the industry, because they know that since the freshers do not have much experience, so there is high chance of error and all, and that's why the company don't rely much on the freshers, and that's why they give very less pay usually, less payment to those freshers. But once you become an experienced person, then your demands also goes high, because with your experience, your productivity increases, your quality outcomes also going to be enhanced. So that's why more and more become you spend time on software development activities, more and more you are going to be valued in the market. Okay. Now let us learn something called software crisis. This is the reason why actually software basically fails. Okay, why basically software fails? That what we call it is the software crisis. It means there is a crisis of very good, effective, reliable softwares in the world. Okay, so you heard many such instances that this software is not working, this software is failing, and that's why people are coming out with the updates. What irritating Windows they are updating, and now and then every day now and then they are updating. It's really very irritating. They may upgrade after a certain period of time, but I don't know what's the reason. They every now and then they are upgrading their old softwares, and it really spoiling time, processing speed, and everything. It's reducing, because of which I think after developing, they are coming out. They are coming out with lot of. Just a minute, let me call.